Here are the steps you follow. I'm going to first separate the x's and y's. And I'm going to leave some spaces too, so watch how I write this. I'm going to have x squared minus 8x, and I'll leave a space, plus y squared plus 6y, and I'll leave a space. Now I'm going to add 3 to both sides so that this negative 3 comes over to the right side as positive 3. So my first step is to separate things. And now here's where the completing the square action comes into play. When you complete the square on a quadratic, you take half of the linear coefficient. So x is the linear term, first degree term. Coefficient is negative 8. Half of that is negative 4. And I'm going to square that, negative 4, and add it to both sides. So I'm out of room here on the right side, so it's going to look a little funny. I should have written a little smaller. And then y squared plus 6y, half of positive 6 is positive 3. And so I'm going to square 3 and add it to both sides. So half a linear coefficient, square it, add to both sides. Now look what we have. This is going to be x squared minus 8x plus 16. And I'll put that in parentheses. Plus, and this will be y squared plus 6y plus 9. And I'll put that in parentheses, equals to 3 plus 16 plus 9. All right, so again, if you add a number to the left side, you got to also add it to the right side, so don't forget to do that. Now both these will factor as perfect squares, and this is x minus 4 times x minus 4. And x minus 4 times x minus 4 is x minus 4 squared. This is y plus 3 times y plus 3. That's y plus 3 squared. So this process creates perfect square binomials out of each of these halves. Once you get a little practice of this, you can jump from here to here, because you recognize that this is x minus 4 quantity squared and y plus 3 quantity squared. You can pick off those patterns. On the right side, let's see, 3 plus 16 and 9 is going to be 28. So look what happens here. I converted this general form into the so-called standard form. And in this form, we can write down the center and radius. So the center is positive 4, negative 3. Remember, it's the opposite signs of inside here, x minus 4, y minus negative 3. And the radius is the square root of 28. Square root of r squared would be r. Square root of 28, which you can simplify. This is going to be the square root of 4 times the square root of 7, which is 2 square roots of 7. So it's kind of nice to simplify those. Well, that's how you do it. I think it'd be a good idea if I work one more of these, just so you can see a different one. And so I'm going to erase the board and put up another one. This one's going to be a little messier, and because it'll involve some fractions. But I think it's nice to do one, work one out like that. So, all right, same as before. Find the center radius of the circle, but this circle is going to be x squared plus y squared plus 7x minus 11y plus 5 equals to 0. All right, so I'm going to separate the terms again. So x squared plus 7x, and separate that, make a space, plus y squared minus 11y, make another space, equals to negative 5. So I brought the 5 to the right side and went over as a negative. Now what's half of 7? Half of 7 is 7 halves. So I square it and add that to both sides of the equation, plus 7/2 squared. And then half of -11 is -11/2. So I square that and add it to both sides of the equation. And as far as factoring goes, I'm going to skip that other step because when you complete the square, you automatically create a perfect square binomial. And so this one ends up being x plus 7/2 quantity squared. It would be easy to verify that by going through all the work. And similarly over here, I've got y minus 11/2 quantity squared. On the right side, we'll end up with minus 5 plus 49/4 plus, square this, I get 121/4. All right, so let's see, what is that? On the right side, let's get common denominators. So to make this a force, it's minus 20/4 plus 49/4 plus 121/4. Okay, so same common denominator. 49 plus 121 is 170, minus 20 is 150, equals minus 150/4. Positive 150/4. Sorry about that. That is a positive number, not a negative. All right, so here's my equation of a circle written in the standard form. I can write the answer. The center is, and I'll write this legibly, hopefully. All right, the center is always its opposite signs, -7/2, comma, positive 11/2. Semicolon, the radius is the square root of 150/2. All right. So why is that? If you take the square root of this, the square root of 4 is 2. We could reduce that further. See, I just realized the square root of 150 is square root of 25 times the square root of 6. 6 times 25 is 150. So that is 5 square roots of 6. So let me change my answer here to 5 times the square root of 6 over 2. 5 square roots of 6 over 2. Don't forget the period at the end of the sentence. All right, so board's a little cluttered, but that's my answer there. This is a mechanical process using completing the square. And if you do end up taking our trigonometry course, you'll use completing the square on similar problems like this. And we go back to that general form of a quadratic I showed you. They'll give you those, and then by using completing the square, you can determine if it's a parabola, a hyperbola, an ellipse, or a circle. And so it's a similar process in order to get the various features of those different kinds of conic sections. So this is sort of paving the way to a more broader application of these ideas. All right, well, next we'll go on to taking information that we know about and finding the equation of the circle.